Hello there, lovely one. It's me, Helen the Great, and I've found a great question for you. Why is it so great? Well, it's got those ugly things called fractions. And I know how much everybody hates fractions. So let's go over it together. We have two terms on this side of the equation and one on this side. The fractions are troublesome. So what we're going to do is get rid of them. How do we get rid of them? Well, first we have to put everything over a common denominator, and that'll be easier if we factorize this first. So let's do a separate calculation that doesn't look so ugly. If you were to do this normally, you'd be very good at it. You know that it's a difference of two squares. So it's x minus 4 and x plus 4. Not so bad, is it? So let's rewrite the equation with those now in it. And the reason why that's so useful is because now it's going to be easier to find the lowest common denominator. What is it going to be? X minus 4, x plus 4. Okay, let's extend that line and it's equals to 1. Let's put on the side that that's what we're going to change the lowest common denominator to, because if we make that explicit now, we don't really have to show many calculations. We can change everything to be over the lowest common denominator and drop the denominator all at once. Now this one needs an x plus 4. So x plus 4 and x plus 4. Why do we multiply both the numerator and the denominator by the same amount? Well, we don't want to change the value of the fraction, and the only way we can ensure we don't is by multiplying the denominator and the numerator by the same amount. Now this 1 is slightly more interesting. We've got to multiply the denominator, which of course is 1, by the common denominator, lowest common denominator. Where did I get that 5 from? Sometimes I surprise even myself. Actually, all the times I surprise even myself. So, plus 4. Now that means at the top we're going to have x, well, let's just rearrange it, x plus 4 and x minus 4. Okay, so let's do the next line, and in this next line I'm going to drop the denominator immediately. Why? Because then I'll take up less space, and that's quite nice when you've got handwriting like mine, isn't it? And of course you're running out of space, which can be problematic. Okay, after this we are going to multiply out the brackets. Once we've done that, we'll be able to solve. Okay, and it was x minus 4. So this is going to be 2x plus 8 minus 8, or minus 9. And it's going to be x squared, and we know it's going to be minus 16. We could do the whole thing, but what we'd find is it would be x times minus 4 is minus 4x, and 4 times x is going to be plus 4x, so they would cancel out. Now what we have over here is a quadratic equation. How do we know it's a quadratic equation? Well, look at that squared. So now we're going to solve for the quadratic equation. Let's rewrite it. I like this orange, so I'm going to stick with it. Okay, and I'm going to move everything over to that side. So I have 0 is equals to x squared minus 2x, and it's going to be minus 15. I know what this is going to factorize to. It's going to be x and 3, negative 5. You can check my calculations if you want. But I'm pretty sure you can also, after all the experience you've had, also factorize this just as easily. The reason we're doing this problem is we want to solve for x. We know that we're going to have two different values for x because we've got two different brackets. And we know we'll have two different brackets because of the x to the power of 2. Let's switch to blue. Blue's nice. The reason I'm switching to blue is so that I can continue the question over here. Now the whole theory about solving for quadratic equations is that if something is equals to 0 and it multiplies something else, doesn't matter what the value is, it will equal to 0. The equation will equal to 0 at least. So I could have x plus 3 is equals to 0, or x minus 5 is equals to 0. And then it's far easier to solve for them. It's equals to 0, and x minus 5 is equals to 0. Well, you know that x plus 3, when what value do we need for x to make x plus 3 equal to 0? We need negative 3. And what value do we need for x to make this equation equal 0? X minus 5? Well, x needs to be 5. Okay, so lovely one. Now you know that you don't have to be scared of anything that has a fraction, because all you need to do is find the lowest common denominator. You'll probably have to factorize one of the denominators before you find the lowest common denominator, but after that, it's all fun and games. Much love.